Imagine for a moment that life beyond Earth isn't just a distant dream, but a possibility hidden beneath the icy surfaces of moons, orbiting the gas giants in our solar system. Europa, Enceladus, Titan, these so-called ocean worlds, could hold the secrets of life's origins, waiting to be uncovered. But how could life, as we know it, have possibly emerged on these frigid, distant moons? Surprisingly, the answer might lie with comets, those icy travelers from the far reaches of space that have been impacting planets and moons for billions of years. Throughout Earth's history, comets, meteors, and asteroids have bombarded the planet's surface. While these impacts were often catastrophic, sometimes triggering mass extinctions, they may have also played a crucial role in the emergence of life on Earth. This is particularly true during the Hadean era, roughly 4.1 to 3.8 billion years ago, a time when Earth and the inner planets of our solar system experienced an intense period of impacts known as the Late Heavy Bombardment. These cosmic visitors likely delivered more than just destruction. They may have brought water and the essential building blocks for life. But Earth wasn't the only target. What about the icy moons in the outer solar system? Those mysterious bodies like Europa, Enceladus, and Titan, which are believed to harbor vast oceans beneath their frozen crusts. Could comets have played a similar role there, seeding these distant worlds with the ingredients necessary for life? Recent research suggests this may be the case. Led by Shannon M. McKenzie, a planetary scientist at Johns Hopkins University, Applied Physics Laboratory, a team of researchers explored the possibility that comets and other impactors might have delivered crucial materials to these ocean worlds. Their findings, published in the Planetary Science Journal, shed light on how these impacts could have contributed to the chemistry necessary for life on these distant moons. To understand the potential for life on these moons, we need to first grasp what makes them so unique. Europa, Enceladus, and Titan are all classified as ocean worlds. This term refers to celestial bodies that have large amounts of water, often hidden beneath a thick layer of ice. Below the ice, scientists believe there are vast oceans of liquid water, kept warm by heat generated from tidal flexing, the gravitational tug-of-war between these moons and their host planets, like Jupiter and Saturn. This tidal heating could create hydrothermal vents on the ocean floors, similar to the ones found on Earth, where some scientists believe life may have originated. On Earth, the deep-sea hydrothermal vents are teeming with life, despite being far removed from sunlight. The energy and minerals released by these vents create a unique environment where life thrives in complete darkness. If similar vents exist on these icy moons, they could provide the necessary energy for life to develop. But energy alone isn't enough. Life also needs the right chemical ingredients, and this is where comets come into play. Comets are often considered time capsules from the early solar system, containing a mixture of ice, dust, and organic molecules that have remained largely unchanged for billions of years. When these icy bodies collide with a planet or moon, they can deliver water, organic compounds, and other essential elements for life. In fact, some scientists believe that much of Earth's water may have been delivered by comets during the early history of the solar system. If this happened on Earth, it stands to reason that it could have happened on other worlds as well. The study led by McKenzie and her colleagues focused on how comet impacts could influence the chemistry on these ocean worlds. They examined how impacts might create temporary pockets of liquid water by melting the ice, providing a habitat where organic molecules could interact and potentially form more complex compounds. These melt pools, as they are called, could act as miniature laboratories where the building blocks of life could come together. For example, consider Europa. With its icy surface and suspected subsurface ocean, it's one of the prime candidates in the search for extraterrestrial life. When a comet strikes Europa, it could create a crater filled with meltwater. Within this meltwater, organic molecules delivered by the comet might react with the salts and minerals already present in Europa's ice, leading to the formation of more complex compounds like amino acids, the building blocks of proteins and therefore life. But could life actually survive such impacts? The researchers explored this question by analyzing the pressures and temperatures that would be generated by comet impacts on these moons. They found that while some impacts would create conditions too extreme for life to survive, others might actually foster the creation of new organic compounds. For instance, on Europa and Enceladus, impacts would likely create pressures higher than what bacterial spores can withstand. However, these same high pressures could also trigger chemical reactions that produce the necessary ingredients for life. On Titan, where impacts are generally less violent due to its thick atmosphere, the conditions might be more favorable for life to survive and evolve. Titan, Saturn's largest moon, is a particularly intriguing case. Unlike Europa and Enceladus, which are believed to have water oceans beneath their ice, Titan's surface is covered in lakes and rivers of liquid methane and ethane. However, scientists believe that there may be a water ocean deep beneath Titan's icy crust. The presence of organic molecules in Titan's atmosphere and on its surface, combined with the potential for liquid water below, makes it a fascinating place to search for life. Comet impacts on Titan could mix these organic molecules with water, creating an environment where prebiotic chemistry could take place. But comets aren't just delivering the ingredients for life. They may also be stirring the pot, so to speak. The impact itself can create shock waves that provide the energy needed for chemical reactions to occur. These reactions could lead to the formation of complex organic molecules, including amino acids, nucleotides, the building blocks of DNA and RNA, and even simple proteins. Over time, these molecules could accumulate in the melt pools created by the impacts, eventually leading to the emergence of life. One of the key findings from Mackenzie's study is that while the conditions on Europa, Enceladus, and Titan are vastly different, all three moons have experienced comet impacts that could have contributed to their astrobiological potential. On Europa and Enceladus, where the ice is thinner and impacts are more frequent, the melt pools created by these impacts may not last long, but they could still provide enough time for organic chemistry to take place. On Titan, where the ice is thicker and impacts are less frequent, the craters created by comet impacts could remain liquid for much longer, providing a more stable environment for life to develop. In all three cases, the researchers found that comet impacts are likely to have played a significant role in the chemical evolution of these moons. While we don't yet know if life exists on Europa, Enceladus, or Titan, the evidence suggests that these ocean worlds have the right ingredients and conditions for life to potentially emerge. Future missions like NASA's Europa Clipper and Dragonfly missions will help us explore these moons in greater detail, searching for signs of life and shedding light on one of the biggest questions in science. Are we alone in the universe? The Europa Clipper mission, set to launch in the coming years, will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. It will search for signs of recent or ongoing geological activity and measure the thickness of Europa's ice, helping scientists determine whether the conditions are right for life to exist beneath the surface. Similarly, the Dragonfly mission will send a rotorcraft to Titan, where it will fly to different locations across the moon's surface, sampling the atmosphere and surface materials in search of the building blocks of life. Meanwhile, scientists continue to study Enceladus, where plumes of water vapor and ice regularly erupt from the moon's southern polar region. These plumes contain organic molecules, suggesting that there may be an ocean beneath Enceladus's icy crust that could harbor life. Future missions to Enceladus could involve orbiters or landers that would analyze the plumes in greater detail, searching for signs of microbial life. While we've only just begun to scratch the surface of these ocean worlds, the possibilities are tantalizing. If life does exist on Europa, Enceladus, or Titan, it would not only revolutionize our understanding of biology, but also confirm that life is not unique to Earth. The implications for this discovery would be profound, forcing us to rethink our place in the cosmos and opening up new possibilities for the existence of life elsewhere in the universe. In the end, the study of comet impacts on ocean worlds is more than just a search for extraterrestrial life. It's a journey to understand the origins of life itself. By studying these distant moons, we may gain insights into how life first arose on Earth and how it could arise elsewhere. The answers may be hidden beneath layers of ice, waiting to be discovered by the next generation of explorers. As we prepare for the upcoming missions to Europa, Titan, and other ocean worlds, the excitement continues to build. These missions will help us unlock the secrets of the solar system's icy moons and bring us closer to answering one of humanity's oldest questions. Are we truly alone in the universe? And if life can emerge in the harsh environments of these distant moons, what does that say about the potential for life elsewhere, perhaps on planets orbiting distant stars? The next decade promises to be a thrilling time for space exploration, as we venture farther than ever before in our search for life beyond Earth. Whether we find microbes beneath the ice of Europa, the geysers of Enceladus, or the lakes of Titan, each discovery will bring us one step closer to understanding our place in the cosmos. The anticipation surrounding these missions is a testament to humanity's unrelenting curiosity and drive to explore the unknown. As we prepare for these ambitious space missions, it's clear that the search for life is not just about answering a scientific question, but about exploring the fundamental nature of existence itself. These missions will not only test our technological capabilities, but also challenge our understanding of what life can be. The extreme conditions on these moons, ranging from the intense cold of Europa and Enceladus to the thick, nitrogen-rich atmosphere of Titan, present unique environments where life could potentially thrive. Discovering even the simplest forms of life in these alien worlds would not only revolutionize our understanding of biology, but also provide profound insights into how life might emerge and survive in various cosmic environments. In addition to the missions to Europa, Enceladus, and Titan, researchers are also exploring other intriguing bodies in the solar system. For instance, the dwarf planet Pluto, which has its own icy surface and potential subsurface ocean, might also harbor clues about the conditions that could support life. Similarly, moons of Uranus and Neptune, such as Miranda and Triton, are also being considered in the broader search for extraterrestrial life. Each of these celestial bodies offers a unique set of conditions that could contribute to our understanding of the building blocks of life. Moreover, as we advance our space exploration technologies, we're also developing more sophisticated methods to analyze the samples collected from these distant worlds. Instruments capable of detecting trace amounts of organic compounds and analyzing their structures will be crucial in deciphering the potential for life on these moons. Future landers and rovers, equipped with advanced laboratories, will be able to perform in situ analyses of surface and subsurface materials, providing real-time data about the chemical composition and potential habitability of these environments. The scientific community is also leveraging recent advances in artificial intelligence and machine learning to analyze data from space missions. These technologies can help identify patterns and anomalies that might be missed by human observers, providing new insights into the conditions on these distant moons. As AI and machine learning continue to evolve, they will become increasingly integral to our exploration efforts, helping us make sense of the vast amounts of data collected from space missions. As we look to the future, it's important to remember that the search for life is as much about the journey as it is about the destination. Each mission, each experiment, and each piece of data contributes to a larger tapestry of understanding about our place in the universe. The excitement and wonder that drive our exploration efforts are shared by scientists, engineers, and the general public alike. The quest to uncover the mysteries of the solar system and beyond is a collective endeavor that embodies the spirit of human curiosity and the desire to answer some of the most profound questions about existence. In summary, the possibility that comets delivered the building blocks of life to ocean worlds, like Europa, Enceladus, and Titan, opens up new avenues for exploration and discovery. While we have yet to find definitive evidence of life beyond Earth, the potential for these moons to harbor life continues to inspire scientists and researchers. With upcoming missions and advancements in technology, we are on the brink of uncovering new and exciting truths about our solar system and the broader universe. As we continue to explore these icy worlds, we remain hopeful that one day we will find definitive proof of life beyond Earth. Whether we discover microbial life, complex organisms, or new chemical pathways, each discovery will bring us closer to understanding the origins of life and the potential for life elsewhere in the universe. The search for extraterrestrial life is a journey of exploration, curiosity, and wonder, and it is a quest that will continue to captivate and inspire us for generations to come. So, stay tuned as we embark on this exciting voyage into the unknown. With each new mission and each new discovery, we edge closer to answering one of humanity's greatest questions. Are we alone in the universe? The answers await us in the icy depths of Europa, the plumes of Enceladus, and the lakes of Titan. And as we look to the stars, we carry with us the hope and excitement of uncovering the mysteries of the cosmos.